look at some larger numbers today. Build an area model for 23 times 34, or 23 by 34. Pause the video and give it a go. Okay, let's see how you did. I know I want it to be 23 tall, so I'm going to use some bigger base 10 blocks. That's 20 and 3, 23, and I want it to be 34 long. Oh my goodness, it's like a puzzle. 34 long. Okay, I have 23 and 10, 20, 34. What would be an efficient way to fill this space? Well, I can see some big areas, so I think I'll do as many as I can with the hundreds. That is much more efficient. Then I can see some places here, I think tens will fit in. Yes, it does. And you may be noticing by now a pattern of hundreds, tens, tens, and ones. This is a pattern in an area model when doing multiplication. Here I can't fit any more tens, so I'm going to get those ones, so many little ones. You may be thinking right now, ooh, how many ones do we need? And I know it's 3 by 4. If it's 3 by 4, I can know that 3 times 4 is 12. So I will need 12 in that spot. And there's my area model. Let's draw it. So it's a big one today. And it has that same pattern of hundreds, tens, tens, and ones. Well, it was 20 and 3 high and 30 and 4 wide, long. So 20 by 30, I can even remove this and see 2 times 3 is 6. So 20 times 30 is 600. Sometimes thinking small is a great way to solve larger problems. Then I have 20 by 4, and if I look over here, 20 by 4, I have 40, and 40 is 80. And I can think small. 2 times 4 is 8, so 20 times 4 is 80. Let's look at my other tens. It is 3 by 30. I can even think small. 3 times 3 is 9, so 3 times 30 is 90, and I can see 30, 60, 90. And we had just talked about our ones. It is 3 by 4, which is 12. Let's add it all together. I have 600, 80 and 90. Here I'm going to think small too. I'm adding them all up. So 9 and 8 is 17, but I have 17 tens, so that's 170, and I have 12 ones. When I add that up, I get 782. So 23 times 34 is 782. Here is a challenge. Try partial product or standard algorithm and see how it compares to our area model. We have done an area model for 23 times 34. Let's compare that to partial product and standard algorithm and see what connections we can make. So let's start with partial product. 3 times 4 is 12. 20 times 4 is 80. 3 times 30 is 90. And 20 times 30, well, 2 times 3 is 6, but 20 times 30 is 600. Let's add that up and see what we get. 9 and 1 is 10, plus 8 more is 18. 782. Let's compare. What do you notice about the connection between partial product and our area model? Pause and discuss. You may have noticed that the partial product has the same parts as the area model. There's the 12 ones, the 8 tenths, the 9 tenths, and the 6 hundredths. We added them up in both problems. Now let's try standard algorithm and see how it compares. 3 times 4 is 12. 2 times 4 is 8, plus 1 is 9. Move over to my tens place. 3 times 3 is 9. I already added that, so 3 times 2 is 6. Add those together. 9 and 9 is 18. Carry the 1, 6 and 1 is 7. I get the same answer both times. Do you see how this is connected to the partial product? Here we have 600. Here's the 90. The 9 and the 2, 92, is the 80 and the 12 together. Let's compare it to our area model. Do you see any connections between standard algorithm and our area model? Pause and discuss. You may have noticed the same as partial product. Here we have 690. Here's the 690. It is this part of our area model. Here we have 92. That is the 80 and 12. It is this part of our area model. Partial product, standard algorithm are all connected to the area model.